Welcome to the Carbon Mini-series within the Exploring Opportunities podcast, brought to you as part of the Future Farming Resilience Support delivered by NIAB, AKC and Savills working in partnership. My name's Elizabeth Stockdale, head of the Farming Systems team in NIAB, and today we're going to explore the science behind the spotlight on lowland peats with my guest today, who is Professor Chris Evans from the UK Centre for Ecology and Hydrology. Hello, Chris.
Morning.
So my background is as a soil scientist in farming systems with a focus on soil health. I have worked in upland livestock systems and I have worked with farmers with highly productive black soils. And there's such a dichotomy there of those kinds of soils in the UK and what that means for farming systems. But before we get into the details of those peat soils and climate change, do you just want to give us an introduction to yourself and what brought you into the study of peat?
Sure. Yeah, it was a series of random events, really. I started out quite a while ago working on acid rain, actually. So that's up in the uplands, does include peatlands, but not just. But totally different science area, really. Mm-hmm. And then I got interested in dissolved organic carbon, which is the brown stuff that goes down the rivers. So I was working in the blanket bogs in the uplands, just trying to understand what's going on there. And then I think realised that the lowlands were kind of where the action is in terms of the emissions and the really big complicated challenges, and I guess I like a big complicated challenge, so that's where a lot of my effort goes now.
So peats are very special, distinct soils, very different from the mineral soils in other bits of the landscape, and they occur in both those upland and lowland landscapes across the UK. But can you just give us a peatland biogeochemist's explanation of what on earth is this peat stuff and what's special and distinct about these particular soils and locations?
Yeah, I do sometimes ask myself why I've ended up working in flat, boggy places, but yeah, I mean, it kind of happens through a sort of failure of the normal sort of carbon cycle, because what happens across most of the planet is plants grow, they decompose, some of that carbon goes into the soil, that then slowly decomposes, and the whole system stays in balance more or less over thousands or potentially millions of years. But in peatlands, and this can happen in various settings, if the ground is waterlogged, all of that carbon that's being produced through photosynthesis falls as plant litter onto the soil, but it can't decompose because the fact that it's waterlogged means there's not enough oxygen for the bugs to break down that organic matter. So it can pile up, and it can keep doing that for thousands of years until you potentially have meters and meters of this stuff, kind of black, amorphous gunge. If you've ever fallen in a bog, you'll know what it's like. But it's absolutely loaded with carbon. So hence the interest, I guess.
And so that relative carbon stock, if we're thinking about tons per hectare, how does it stack up in peatlands compared to something like woodlands that are a different focus for carbon storage and in the context of climate change?
Well, it's huge. I mean, there's as much. I'm going to quote some oft-quoted numbers probably, but there's as much carbon in, say, 20 to 30 centimetres of peat as there is above ground in a tropical rainforest. It's a huge amount of carbon. And then you think about some of these peatlands being meters deep, and suddenly they're some of the most carbon-rich ecosystems on the planet. Within the UK, I believe we have about 3 billion tonnes of carbon in peat, which I think is most of our soil carbon, and it's something like 20 times more carbon than there is in all of our forests. Okay. So not to suggest forests aren't important, but if you ignore the peatlands, you're kind of missing something.
And so if we're thinking about this net zero thing, which is that balance of inputs and outputs, the big store in peatlands is important because it's a store, but yeah. How does that play in that conversation around net zero and emissions?
Yeah, I mean, that I think we've learned a lot, certainly in the time I've been involved. I think when started out, there was this idea that because peatlands were full of carbon, that meant they were, intrinsically helping us to, remove carbon from the atmosphere and combat climate change. And of course, they do that slowly over a very long time. They cool the planet, and they have done. But the reality now across most of the UK and indeed a lot of the world is that we've drained these peatlands for many and various things. And by doing that, we've let the oxygen in. And so that process that locked the carbon away no longer works. And so now this stuff's going, and it can disappear a lot faster than it forms. So when actually what we're looking at is quite significant carbon dioxide emissions from these decomposing peatlands. and that's true in the uplands, it's true in the lowlands, it's true under forestry, it's true all over really. So unfortunately, peatlands aren't exactly part of the solution right now. They're part of the problem because of what we did to them. So we need to fix that. If we're going to get to net zero, we need to. It's something in the UK like it's about 4%. We think 3 to 4% of our greenhouse gas emissions are coming from peatlands. And coincidentally, it's about the same number globally. So if you don't fix that, you've got a challenge on your hands. So it's about, latest figure, something like 16 megatons of CO2 emissions, or equivalent CO2 emissions from peatlands in the UK. If we've got to get to net zero, we've got to ideally bring that not just down to zero, but actually turn some of these peatlands back into carbon sinks, which is what they used to, and then they can actually help us a bit with the whole net zero thing.
So if we look at the Committee on Climate Change net zero scenarios that drive or at least inform government policy, I know you were a little bit involved in setting those and thinking about peatland restoration targets. How might that feed into conversations around land use and management change in these landscapes?
Yeah, I mean, it clearly does. I mean, I was a little bit involved in those scenarios, but somewhat by accident. I was asked what I thought might be a suitable target, and I thought, in a way, it was a kind of what-if scenario, but it's ended up in the sixth carbon budget to some extent, which is a bit scary because they're big numbers. I mean, the ambition there is huge to restore all upland peat pretty much, so that the carbon loss there stops, and then variously re-wet or manage lowland agricultural peatlands differently to not necessarily fully halt their emissions, but bring them down as low as we can within a sort of partly farmed ecosystem. So it's hugely ambitious. I mean, what it does, I guess, is it's a bit of a reality check. If you want to get to net zero, you have to really go big, not just with this, but with everything. And even then, it's hard. At the same time, I think it's rather easy to set a very ambitious target, 30 years out at a UK scale. What's actually very difficult is saying, okay, how are we going to manage this field differently? Within a commercial farming system in particular. And so there's a bit of a disconnect, I think, between the ambition and the reality on the ground. And of course, I'm not the only person that's noticed this, and there are projects being set up and funded now trying to find ways to address this challenge. And I don't think any of us know the right answer. There's probably a bunch of right answers or partly right answers. So we need to try a lot of different things and work with the farmers, which we'll probably come on to.
Yeah. So if we briefly just do upland peats, because they are distinct, I think the challenge, as you've described it, is probably bigger, or at least there are more unknowns in lowlands. But let's briefly just do upland peats. Yeah. Those in the farming context are usually relatively low intensity grazing systems. They're often already integrating game management and conservation. The intensity of land management there has been in general less. That doesn't mean they haven't been drained, they have. But how does that mean restoration targets in the uplands might affect farmers? What might those farmers notice or need to be paying attention to?
I mean, there's a lot to it because it's a vast area. It's I think 85% of all of our peat is in the uplands. It's what's called blanket bogs. So these things kind of, as the name suggests, kind of blanket sort of lower relief areas of the uplands. There's a fair amount of it that's under conifer plantations. That wasn't a very smart idea, but so there's discussions as to what to do about that because that involved drainage. And there's a tension there actually between, government tree planting ambitions and government peat restoration ambitions. At some point, they start to run up against each other. From a farming perspective, a lot of this land, well, some of it was never really farmed, still isn't. Some of it's managed for grouse and other game like deer. Some of it's got sheep on, a lot of it's fairly unproductive, I would say, and a lot of those ditches that are out there, of which there are, I don't even know, millions of kilometres of ditch, probably. I think most of those were funded with government subsidies back in the 60s and 70s, with the idea that they'd boost agricultural production, which I don't think they really did. In fact, they're quite good at trapping sheep. So I think most farmers are not particularly wedded to having drained peatlands, in my experience. I think they're not going to well, there's a lot of grant schemes out there and there's a lot of impetus to try to block those ditches, and I don't see an obvious downside if you're a farmer to if someone's willing to support you doing that, it might actually be a good thing. But actually, a lot of areas, the farmers are taking their sheep off the hills anyway, these areas, because they're not very productive.
Yeah. So if we switch our focus into that complex world of the lowlands, when we even do that, there are of course several different large areas of actually quite distinct peatlands in the lowlands with different formation processes. Can you just give us a quick snapshot of where lowland peatlands are in the UK, particularly in England, and what's going on there?
So they're not just in England actually, but a lot of, certainly my work and a lot of the policy focus has been in England. So I'll probably end up talking mostly about England, but should note there's plenty in Northern Ireland, Scotland, and a bit in Wales too. So it's not just. It tends to form in kind of river deltas, I suppose, or sort of low-lying areas where the rivers were sort of trying to get to the sea and failing in a way, areas like the Fens and the Somerset levels. And so as sea levels were shifting relative to land levels, you tended to get these vast areas of waterlogging, since the Ice Age, basically, and that caused this peat formation. And these landscapes were, they evolved initially before and then with humans. They were used as mostly extensive grazing. I mean, Somerset, I think, means summer grazing land, doesn't it? So people would have their livestock up in the drylands for the winter, and then in the summer this was rich grazing land, and then that all kind of changed a couple of 100 years ago with the industrial drainage of the Fens and other areas, basically by rich landowners, and then that allowed them to sort of take ownership of what had previously been common land and manage it much more sort of at scale, mainly for crops. And so what we see now is a completely different landscape to what would have been there a few hundred years ago, but also generally, I think.
Yeah, and I think we use terms Fens, Somerset levels. There's Lancashire mosses.
Yeah.
We have levels around the Humber in the Humber Head.
Yep.
I think Lancashire, the mosses and lowland mosses are probably just worth talking us through because they're quite distinct, aren't they?
Yeah, sorry. Fens is a tricky one because the Fenland area is a place, and Fens is also a type of peat. It's not a British word. I think it comes from the Netherlands, and that's a peat that's formed through sort of groundwater flowing in or river water. So it tends to be quite alkaline. It tends to be quite nutrient rich, and it tends to support things like reeds and certain types of tree like willow and alder. Whereas the mosses are what are called raised bogs. So these probably started out as fens, and then the peat just kind of grew until it got higher than the surrounding land. And I won't go into how that can happen, but bogs are basically very good at retaining their water, so they can form their own sort of rain-fed hydrological system. And as that happens and the water's coming from the atmosphere, it's much more acidic. There's a lot less nutrients. And then you tend to get plants like you see in the upland, so like sphagnum mosses and sedges and things that can survive without much nutrients. So they're different systems, but yeah, if you drain them hard enough, they end up looking a bit the same in the end.
So let's just talk about that change, that management change, which is not, it's ongoing, but it's not the biggest changes haven't been recent. There are often hundreds of years old. There are some that are only decades old. But what happens in a natural peatland when it's drained? What are the processes that happen?
Yeah, so the first thing is a kind of physical collapse because the water's keeping the peat buoyant. So when you first drain, the land just drops, potentially by like a metre, because the peat just kind of collapses and shrinks. And that process actually continues over time for hundreds of years, but at a slower rate. So there's a kind of physical process, but at the same time, there's a sort of biological, chemical process of accelerated decomposition. So once the air gets in, there's actually, this is bug food, really, once you let the air in. So the bugs get going on it, decompose it, and that's releasing CO2. And so that CO2 is what used to be the soil. It used to be the peat. Mm-hmm. So you're losing the peat. And so actually, again, you're losing height. And so if you think about some of these areas, the same in the Netherlands and North Germany, the reason they're below sea level is this process. They didn't used to be. But they've lost meters and meters of elevation through this combination of physical and biochemical processes. So now what was originally a system that could be drained using gravity, they then had to introduce wind pumps to try to get the water up and out into the rivers. So the river's now higher than the land. and then the level got even lower, and now they have to use electric pumps, and you're having to lift water meters to get it out to sea, which is, seems kind of crazy, but that's how it works.
Yeah.
To keep land dry.
Yeah, and of course we've also had settlements in those areas. So often this conversation is also around flood risk management and protection of settlements. And
yeah, and I mean, people, if you look closely, people in the past weren't too daft. I mean, if you look at somewhere like Somerset, all the houses, apart from anything that was built since about 1970, they're all on the ridges. So actually, no one was getting their property flooded when the moors there used to flood. But people have sort of forgotten that. I mean, I guess the planning authorities forgot it too, because they've started building things in places that are just intrinsically flood prone, which does create a problem because people don't really want their houses flooded, understandably.
yes, so that complexity, I think, of that whole community involvement in this discussion around land use change makes this even more challenging. If we're thinking about this in terms of carbon and emissions, are there particular factors that affect the amount and the timing of those emissions, or is it just if it's drained it emits, and if it isn't, it doesn't?
Well, that's the kind of bottom line. The more it's drained, the more it emits. I guess that's the additional thing. So the more the deeper the peat and the further you drain it, the more carbon there is for the bugs to get to work on, basically. And so the more emissions you'll see. And in terms of timing, it will happen when the system is warm and fairly dry. So this summer we've just had was probably pretty good for decomposition. If it gets super dry like it did at the peak last year, when it was really that extreme drought and heat wave we had, it may have actually got too dry for processes to go on to some extent, so they did slow down a bit. But in general, the more you drain, the more emissions you'll get. And while there are things you can do in terms of farm management, if you can't get the peat wet, we think there's a limit to what you can do to stop that process.
Okay, so just in terms of these systems gradually losing peat, does that mean whatever happens in these landscapes, the end of farming as we know it, when that's a changing thing, I'm aware, but say farming, that drained dryland farming system in this area, not actually working as well as it did 100 years ago, just because those soils are gradually decomposing and being lost?
Yeah, I mean, I think you can, there are places, Cambridgeshire and around that area, where pretty much the entire original 4 meters of peat is gone. You still tend to have a sort of organic, rich, clayey, silty soil, and you can grow crops on that, but it tends to be cereal crops. So what's lost is that fabulous stuff that looks like looks like what it is, which is a load of grow bag peat, which is super. You can level it, you can manage it with precision, and you can grow high value things like salad crops on there. So it's very valuable land. There's not so much of that left, and it's going. So there is a kind of end in sight, I would say, for that kind of horticultural management, unfortunately. So yeah, I mean, we are looking at what the options are there. What can you do to slow the loss or halt the loss? Can you still grow on the fen? Do you need to move somewhere else? Do you need to think about indoor production a bit more? Some farmers are doing that. Or do you sort of accept that you're going to lose this soil, but we need to do that for the sake of our food security and our economy and our society? But that's a difficult trade-off, because obviously it's leading to a lot of emissions.
So in terms of those management options in these lowland peat landscapes for the future, it sounds like the heart of that is around a conversation about water management, which is, of course, much bigger than just a farm scale decision. It's a cooperative thing. In most of these landscapes, we would have internal drainage boards or equivalent organisations cooperation on water management.
Yeah, and I think these are interconnected landscapes. There are some farms that have got complete control of their own water, but there aren't many. Usually they have to work cooperatively. And sometimes there's a limit to what they can do. And that's the sort of legacy of, the clues in the name. They were drainage boards. Their job was to just get water out, ship it out to sea, essentially, or at least get it into the main rivers. And that culture, to some extent, still persists. But I think what's needed now is water management, not drainage per se, because having a situation where there's too much water in winter and you chuck it all out to sea, and then you have extreme droughts in the summer and everyone's screaming because there's not enough water, it doesn't make much sense for carbon or for farming. So actually improving our ability to retain water within the landscape, whether that's reservoirs or areas of land that you allow to get wet, like washlands, expanding those, I think that's probably where this needs to go. So the water's there and can be used, and then hopefully what happens is then the farmers have more flexibility individually and collectively to do different things.
I think we're seeing in the countryside stewardship scheme, as it evolves, some more options, paid options there for farmers around re-wetting at field or part field scale.
I think this idea of partnerships, it's like, what do you do with common land, and particularly in the uplands, it's the same thing. You need everyone to be on board with it, because if you've got 10 farmers who want to raise water levels and one who really, really doesn't, you're constrained by the one that doesn't. So it needs a kind of collective effort and the incentives to make that happen. Obviously, I think what I saw in the past was a lot of people encouraging farmers to do things differently, but it wasn't obvious what was in it for the farmers other than possible bankruptcy. I think that's changing. I think there's people looking at how to finance this both publicly and privately. We're not there yet, but I think that all the money that's going into carbon offsetting and all that sort of thing, although it gets a bad name, actually it's got potential, it just needs to be done in the right way, in the right places.
So I think we're still at early stages of really having a blueprint or a way forward for these lowland peat landscapes, but there's certainly activity, the Lowland Ag Peat Task Force, farmers themselves starting to come together and work with conservationists in these areas. I think these are all have potentially good outcomes, but what would your top tip, your end of the science reflection on this say? What should a farmer who's sitting looking at their lowland peat farm be thinking about, and what could they be doing now, or what should they be doing now?
Yeah, I mean, it's really difficult, because I think there's a danger of scientists of coming in and saying, right, raise the water levels everywhere, and then I have spent enough time now talking to farmers who say it's not that easy. This land is not flat, it's not uniform. I might be able to do it in this field, but I can't do it in that field. So I think the first thing is probably look across the whole farm and the adjacent farms and the landscape, and look at where the opportunities actually are. And I know there's work going on with this. You're involved in Fen and Soil, which is great because it's farmer led, and I think it needs to be, just to see where the opportunities are, what's actually practicable. As a scientist, I can help. We can make measurements, we can say what we think might work. We might be wrong, but if we don't try it, we won't know. And try and help people target, do the right things in the right places, basically, and make sure that they actually deliver the outcomes that people think they will. That's a bit of a Weasley answer, because I think there's some areas where you should just be able to drain less. There's over drainage of land for various reasons. Get more water storage into the farm, into the landscape, so you can keep the water high in summer rather than just watching it all drain away. People like the Environment Agency have got a role in all of this too, because some of the regulations don't necessarily help. And they know that, they're working on it, but it's, there's a lot of sort of historical rules and regs to unravel for the kind of new reality we're looking at here, and so there's a lot of work to do.
And I think, for me, and you're right, I am, at least in the Fens, working with some groups of farmers, having a look at some of these things. And the thing I think for me is it's really important that farmers don't sit on their hands and wait to be told what to do, but actually get involved in shaping what that might look like going forward.
Yeah, absolutely. I mean, I think, having referred to the sort of slightly shouty things going on in some of the uplands, I actually think it's been much more sort of civilized and collaborative in the lowlands. And I think it's not that everyone agrees by any means, but everyone's talking, and I think everyone accepts that there's no single, we're not going to re-wet the lot. Paludiculture, wetland farming is an option that could be very effective in some areas, but it probably won't work in others. We still need to produce food. Where are we going to do that, and how? If we shut that down and move to imports, that hasn't fixed climate change. That's probably made it worse. So, I think there's a reasonably sensible conversation going on with, increasingly actually farmers, through things like the DEFRA task force, actually helping to drive the agenda much more than just, sitting and waiting to be told things that they don't like the sound of, which is great. I think it's productive and hopefully going in the right direction.
Thank you for your time. You never know, we might come back and pick your brains when some of the project work that you're doing starts to yield those clues into which direction management might go, or if there are any interventions. But I think it is important to recognise, we talk about this mosaic landscape and there being no silver bullet. I think that's really important for us to bear in mind as we think about this going forward.
Yeah, I think they're probably fine with us. Don't start farming just yet. I mean, look at the options. Try to use the land as in a way that will conserve that soil carbon for everyone's benefit. I think it's to the benefit of farming in the long run as well, but it might need changes in how we've been doing things.
Thank you.
Thank you.